Quantum numbers encompass the entirety of an electron's location. These can describe the specific and general location of the electron, the orbit that the electron habits within the subshell, and the direction the electron is spinning. Each electron in an atom has a unique set of quantum numbers, which are based on the possible locations that electron can occupy.
The principal quantum number is the number for the shell, and it is represented by the letter n. It could equal to 1, representing the first period, equal to 2, representing the second period, and so on. It is the general location where the electron is found. The secondary quantum number, represented by the letter L, is the number for the subshell. 0, or the S subshell, has a spherical shape. 1, or the P subshell, has a dumbbell shape. 2, or the D subshell, has a four-leaf clover shape. And 3, the F subshell, has a jack's shape. To have one subshell, you need to have all the ones before it.
The magnetic quantum number describes the number of orbitals that are contained in a certain subshell, as dictated by the second quantum number. The formula for this is 2 times the second quantum number plus 1. Every subshell begins with a 0 and expands with 2 additional directions per L value, one in the negative and one in the positive. The first orbital has only one option as a spherical subshell, while the second has an additional 2 directions, which force all 3 orbitals into dumbbell shapes. Each orbital can only contain 2 electrons, each with a different spin quantum number. The spin quantum number, the direction in which the electron field flows in a sense from pole to pole, which only have 2 possibilities for spin quantum numbers. It can be positive and negative, or up and down, basically any 2 opposites. The electrons cannot be in the same orbital without different spin quantum numbers. Electrons are both negative, so by their nature repel one another. If the 2 electrons have opposite spins, however, then the magnetic field of one electron will flow from one pole of the first electron to the pole parallel to it on the second electron, thereby pulling them closer together in order to overcome the strength of the repulsion created by like charges, and keep them in the same orbit.
The element lithium has 3 electrons. The first and second electrons are in the first shell, the S subshell, and occupy the same orbital. Therefore, they have opposite spins. The third electron is in the second shell, also the S subshell, but is the only electron in it. The element neon has 10 electrons in total. The first shell, n equals 1, contains 2 electrons, while the second shell, n equals 2, contains the other 8. The second shell contains both an S subshell and a P subshell. The P subshell contains 3 different orbitals, each containing 2 electrons with opposite directional spins.